implementation, we all know people constantly create VMs and delete VMs in their environment. It's not a static environment, right? And that's the beauty of it. Previously, if you had to provision a physical system, it used to take days. But with the VM, it's minutes. So you have that ability, and people make use of it. So if you do that on an ongoing basis, you create these pockets of holes within your LAN. It's similar to a defrag in your Windows environment, right? You create these pockets of holes. But what you want is the ability to go reclaim all this space back. So if you have a 2 terabyte LAN and there are these pockets of holes, you want the ability to go reclaim that back. You run a command, you reclaim it back. And with 3PAR, you have that unique ability that you can go reclaim this space back and be thin on an ongoing basis. Next slide. One of the, you can go through some animation. Okay, so one of the key things 3PAR's benefit is this autonomic storage tiering. What essentially it means is my data at the right tier for the right cost, right? Is my data on the right tier of storage at the right cost? Especially with VMware, it makes a lot of sense. VMware has this concept called SIOC, which is Storage I/O Control, wherein it throttles the VM's performance based on customers' designation of priority of their VMs. If they designate VM1 and VM2 to be a high priority VMs, it will go throttle the I/O of the other VMs if it need be, if VM1 and VM2 do not get the required performance, right? What autonomic tiering does is, on an ongoing basis, it will look at the data and say, hey, if you designate that this data in your environment, if you have, let's say, a high-performing tier and a low-performing tier, and if a portion of your data always is being accessed at a higher rate than the other, it will take this data and move it to a different storage tier based on the user designation. And what that means is, in a VMware environment, let's say you designate VM1 and VM2 to be high priority VMs. VMware does its job by monitoring the performance and throttling the I/O. And we know that if VM1 and VM2 is being accessed very heavily on an ongoing basis, it depends how long you want to monitor and things like that, but on an ongoing basis, if it is being accessed very heavily, we will take the data and move it to a higher tier in your environment. Say, for example, if you're running SSD and nearline drives, you can automatically move the small set of data to your SSD drives. So a combination of rapid measuring from VMware based on their SIOC and sustained measurement from the 3PAR storage gives you an optimal implementation to say, you know, the data that's important to you has the highest performance and it does reside on a highest tier within your storage infrastructure, right? So it gives you best of both worlds when you implement VMware on 3PAR. Next slide. So the next immediate question is, okay, fine. Well, what are the things that are coming, or where is HP investing to make sure that we continue this momentum, right? And initially when we talked about, there are a couple of things that we said that are important, right? From a performance point of view, right? We'll always be looking at how can we enhance the performance. And from integration, I did mention that we have been constantly working with VMware. Now more than ever, we'll be working very closely with VMware and Hyper-V and all the virtualization infrastructure to make sure that we have the right investment, make sure we have the right integration of what the customer needs. And similarly, from an availability and efficiency point of view, we'll make sure that we understand that once you deploy or consolidate or look at 3PAR storage as a consolidated framework, we understand that it's not just one application or one customer. It's multiple applications, multiple customers, and availability becomes really important. Next slide. From an HP point of view, we are working very closely to work with this cloud system matrix, which gives a single pane of glass for HP customers to manage their entire ecosystem, whether it's from a storage point of view, from a networking, from a server point of view. You have a framework that you can use to go manage your entire ecosystem. And this is pretty high on our list of integrating within the HP portfolio so that HP customers do get an entire or a single pane of glass, I should say, to manage all their HP portfolio. Next slide. And again, going back to the simplification and things that we have been working on, we will continue and make sure that we do integrate with VMware and other hypervisors to make sure that we provide the level of simplicity that customers need to go manage their infrastructure. Next. And I'll call on Eric. He's a 3-Power customer, and he will go through their implementation and how they have implemented VMware in their environment.
Okay. So we've been a 3-Power customer for about 3 years now. I work for Cornell. Next slide. So I work for Cornell. We're based in Manhattan. The main campus is based actually in Ithaca. Main campus is based in Ithaca, but we're pretty much autonomous from the main campus. So we deal with all the services for students and doctors and researchers, independent of everything else that the university is doing. Next slide. Some of the challenges that we had prior to using 3-Power is we were a EMC customer, and we had purpose-built arrays that we had for all the different services that we provide. So all our clinical systems were on one array, email was on another array, we had some SQL on a different array, and it became clear to me that it's difficult when you start scaling out in large volume, because what you do, we had 6 EMC arrays. And I didn't think that, we're not that large, we're a mid-sized organization. What happens when you get to 10, 12, 15? So we knew we had to find a better solution. We're in Manhattan, so we don't have a lot of space to fill with. It's always a challenge for us to try to squeeze things into small spaces. And we don't have a lot of power to deal with either. So when we need more power, it's not just call somebody and run them line. It's a large undertaking that probably won't happen very quickly. It might take a couple of years to get more power, if at all. So scaling out in the EMC model was not going to work for us on an ongoing basis. And we were starting to see some performance issues with trying to put mixed workloads on some of the systems that we had. So we started looking at alternate solutions to solve a lot of these problems for us. So when we first started looking at 3-Power, I knew that we had found something different, a new solution. Some of the things that we liked about 3-Power is the ability to have multiple front-end fiber channel ports. So we weren't limited to 4 front-end fiber channel ports. As a matter of fact, one of the first things that we did, we bought expansion cards and we put additional front-end fiber channel ports. Also, on the back end, everything is addressable from the nodes. So there's multiple back-end fiber channel ports that are addressing all the disks. And we didn't run the potential on the front end to saturate a particular pipe with something that we were doing. So we knew that we were going to be able to scale a lot better, and we knew that the storage efficiency was going to be a lot better with 3-Power. As I said, we knew that we were going to be a huge VMware customer, and we had just embarked on Blade systems. So we knew that with the Blade system that we were going to be able to manage our environment a lot better with the C-class Blades. And we knew that we were going to be able to scale very well with 3-Power. And VMware was, making a big push at that time. So we knew the combination of the three was going to be, a pretty good fit. It's worked out pretty well so far for us. So that's not me. One of the other great things is that it's easy to provision storage. So I can pretty much sit somebody down and have them provision storage in a very short period of time, probably less than 5 minutes. In the past, where we had to keep track of rate groups and what disks were laid out for what workload and what volumes were going where, we didn't need to do that now. So we just basically let it run. So provisioning storage became monumentally more easy for us. So one of the things early on is we had this idea in the old model where we needed fiber channel disks for certain workloads, and we were going to use nearline or SATA disks for other workloads. But pretty quickly we began to realize that we weren't really seeing a great performance advantage by going to fiber channel. So one day I said, hey, let's try running this on our nearline drives and see what happens. And so some of the things that we saw were that it was very cost effective, obviously. The costs are somewhere 2.5, 3 times less for the nearline drives. And the performance characteristics were essentially the same. You weren't really seeing much of an advantage. So because of wide striping, because you can take advantage of the entire pool of disks that you have, as opposed to just 7 drives in a 6+1. And also that we have no sense of a spare drive. So there's spare chunklets, but we can utilize all the drives for I/O and not have just drives that are sitting around doing nothing. Next slide. So one of the other things is we were pretty sure that we had a lot of allocated volumes that had no written data or had very little written data. So we wanted to find a way to save some money, and one of the ways was with thin provisioning. So with thin provisioning, we didn't have to allocate a terabyte written space, actually space that was going to be dedicated for VMs. We realized that we could allocate a terabyte, but in actuality, only 440 gigs was actually being written for that long. So we had that excess capacity to do other things, run other systems, run other workloads if we wanted to. So we were able to consolidate down the amount of storage that was actually needed and able to drive down the cost of providing these services to our customers. One of the big systems that we run, the EMR, Electronic Medical Record System, we were able to reduce the cost from $20 per user to $12, which is pretty significant. Next slide. So this is our current configuration. We have 2 arrays. So we went from 6 to 2. And one of the great benefits that we saw was we didn't need to buy everything up front. We were able to grow as we needed the space and the I/O performance characteristics. We started off with an S400 with 2 nodes. And now we're at an S400 with 4 nodes. We had 20 drives originally, and now we have 240 drives. But we were able to grow that as we needed it. We didn't need to make a huge investment up front. So we consequently then bought, after the S400, we bought a T400. That's gone from 2 nodes to 4 nodes as well. And we run a variety of different operating systems. We run other applications besides VMware, and we run them on the same pool of disks. There's no segmentation of workloads or anything else that's going on. But we run SQL, we run Exchange, Cognos, Cache, one of our major databases, which EMR runs on the Cache database. Most people probably know what that is. It's specific to just EMRs and things like that. I never heard of it before I started working with it. And we also run Oracle on it. So we were able to reduce our CapEx. We were able to reduce the footprint in the data center. So we took those 6 arrays, we reduced them down to a single frame. With it's running 240 drives now, but we took those floor tiles and we consolidated it down. We could use that for other things. But consequently, since we were using VMware, we were able to get really good consolidation rates. So things just sort of started disappearing from the data center, which is a good thing for us. Next slide. I'm not sure this.
That's me, actually. Thanks, Eric. This is a slide to just highlight where you can get a little more information on what we did today and how 3PAR can really benefit you guys in your environment. Right? We have, as somebody did point out, that there is hands-on labs and I also heard